Hi guys, welcome. This is the second of the two sessions to get you started with Python and hopefully to get you motivated to join us for the 30 Days of Python series. So thank you for joining in today. When I'm looking this side, by the way, I'm looking at the chat. So hi guys and welcome. Sebastian, Andy, Hitesh, hi there. Thanks for chatting in the chat and welcome. Today we're just going to be looking at a little bit about Python, some of the fundamentals. We're going to be building our first project. I'm going to tell you a bit about what programming is, what it's about, why it works, and sort of how it works and what's important about it. And I'm also going to tell you a bit about the 30 Days of Python series. So hopefully you guys can hear me and see me. And it's not too choppy. We had some issues with the choppiness of the stream yesterday a little bit, but hopefully today we will be okay. Will this be recorded? This is going to be recorded and available until tomorrow, because tomorrow, the first day of the series, is coming out. And today we're going to cover some of tomorrow's content, and so day 1 and day 2's content. So this will be live or available until tomorrow, and after that we'll take it down as the series sort of begins. Nice one. Glad that you guys can hear me. Awesome. Please do let me know if the quality is not good or you get a lot of choppiness. I'm streaming off my laptop, and yeah, it's not the best. Pretty good laptop, but you know, Macs, they get very hot, and then they start throttling or they start slowing down, and then you can't do anything with them. So let me tell you a little bit about 30 Days of Python then. 30 Days of Python is going to be a series of primarily blog posts that we're going to release one per day. And every day is going to cover a piece of content about Python. So some examples might be numbers, variables, printing things out. We might cover strings, we might cover lists and tuples or dictionaries. You know, all these sort of different topics that we'll cover. A topic or a small related group of topics each day. Together with each blog post, we are going to have a bunch of exercises for you to practice what you've learned, to sort of cement that knowledge. Then every 3 days and every 7 days, so days 3, 6, 7, and so on, we are going to have a project for you to try out as well. So we've got all the content, which is really beginner friendly, really well written. Phil Best, who is in the chat right now, has written the series, and it's really good. So we've got all the content, we've got all the exercises, we've got all the projects. So we think that all of those things together are really going to help you kickstart your Python learning. So yeah, we're going to be doing that. And the aim of the series is to help you build a strong Python foundation. So it's not to teach you everything there is to know and do about Python, because that would be impossible in 30 days, but to give you a very strong foundation so that you can go and tackle any Python topic or project that you want. That does not mean you can then go and do anything without learning any more Python ever again, but it does give you the strong foundation that you can then go and tackle other things. So we're going to help you connect the dots of Python in the critical initial stages of learning to code, so that as you learn more, things make sense because you've got the foundations all ready. So today, like I said, we're going to help get you set up so that you can start coding, you can follow the exercises in the 30 Days of Python series, you can complete the projects, and so forth. We're going to talk about some of the most important things in programming, some that are not often mentioned, and then we're going to teach you some Python, and then we're going to build a quick project to help you cement these new skills. So the session is going to take about 45 minutes. Yesterday we took an hour because we had some Q&A at the end, but it's going to be about 45 minutes or so. If you have any questions, use the live chat, and we're going to be there to help you out. So, Aidan, is there any free or really cheap offline editors I could use to get started coding my own stuff? Yes, absolutely. You can use Visual Studio Code. That's probably one of the most popular nowadays, and you can use it to code any language, really. Or you can use PyCharm Community Edition. That's a Python-oriented editor that you can use. Phil already said the same stuff. Nice. I see you guys chatting about that. So let's continue with the session then. By the way, hello Aidan. Good to see you here again. So first and foremost, and a question that's often left unanswered when you're learning to code is, what is programming about? Why is it useful? What do programs do? How do they behave and why? And it's actually only something I really understood a couple of years after completing my degree. So I did like 4 years of my degree, and then I was still working for a company for a few years, and finally understood what programming really was about. At all levels, programming is about data. Programs receive data, they manipulate it in some way, and then they produce some output. That's really what programs are for. Many programs receive data from users and they then display data to users, but other programs receive data from other programs and then send data to other programs. And there's a lot of these programs that only communicate with other programs. Indeed, whenever you use basically anything, such as a web browser that we're going to look at as an example in a moment, web browsers communicate with hundreds of other programs at all times in order to accomplish the final thing, which is displaying a website and allowing you to interact with it. I can see you guys are asking about how to register for the 30 days of Python and all that. It's all going to be free. You don't have to register. All you have to do is read the blog posts that we will be releasing for free publicly on our blog. If you follow us on Twitter or join our Discord server or both, then you'll get announcements whenever we release new stuff. So programming is about data, receiving data, manipulating it, and producing output. And as an example, we've got a web browser, for example. I'm going to show it to you right now, what the web browser looks like. And here we've got REPL8. I'm going to go into detail about what this is in a moment. But browsers take input from users. For example, if I and you can see this, for example, if I hover over any buttons or start typing up here, and this is my input. This is the user input that the browser is receiving. And the browser then manipulates the data. It interacts with the code that makes up this website and sort of decides what it has to do. And eventually it updates what I see in front of me to show me some output. In this case, it's this list of recent REPLs that I have made, for example. But this happens in all programs. All programs take some user input and then sort of decide what to do with it, manipulate it or change it, and eventually show some output. Another example of a very popular... oh, sorry about that. That was not intended for right now. Another example of a popular program that is very simple when deconstructed is something like WhatsApp, the chatting app. WhatsApp is a great example of an app that simply... And I say simply and I mean it, takes some data from users, that's your messages and who they're meant for, and then it manipulates it, it stores it in a database, and then communicates to the intended recipients that they can now load them, and the intended recipients can load the messages and read them. So users sending data, that's the program accepting data, the data that it's going to work with, then it processes it by storing them, and finally it displays it by allowing recipients to see messages. So that is what most programs are about, receiving data, processing it, and displaying it. And if you think about any other computer program, I promise that you're going to see that this is how they work. They take some input from you, and then they do something, and then they display some data back. The very name computer comes from computation, which means calculation, and computers were made to calculate stuff, aka process data. So, remember this while coding, and never forget it, because your programs will be receiving, manipulating, and displaying data, and even when you're writing individual lines of code, those lines of code are going to be about doing something to some piece of data, as we will learn as you go through the series over the next 30 days. So yeah, in order to write any code though, we need a place to write and run our code. So where might we want to do that? That's where REPL-IT comes into play. I recommend that you use a website called REPL-IT in order to write and run your code. REPL-IT allows us to write and run code right in the browser, and it's super flexible and powerful, and it's very easy to get started with. You don't have to install Python, you don't have to install any programs to let you write your code and run it. So it's all very simple, but it can do everything that you could do if you installed it locally. If you already have Python installed locally, you've got your development environment like PyCharm or VS Code, and you want to use that instead, feel free to use that today and as you go through the 30 Days of Python series. Totally up to you. But if you don't have Python installed already, then let's take a look at REPL-IT. When you load up REPL.it, you're going to land up in the homepage, but I recommend that you create an account in REPL-IT, because that way, whenever you create any new projects in REPL-IT, they're going to get saved to your account under My REPLs here on the left, and you'll be able to access them. So whenever you create a new program, basically, and whenever we start a new day in the 30 Days of Python series, I'm going to recommend that you create a new REPL to keep your code there so that you can then go back to it and refer back to it. So what we're going to do now is going to create a new REPL. It's very straightforward. Just go to the top right, click on New REPL, and select the Python language. Notice that Python might not appear here for you, so you can type Python here, and it'll show you the Python results. You can see that Python is one of them, but then you've got Python 2.7, Python with Turtle, Pygame, and tkinter, and you need to choose Python. Python 2.7 is an older version of Python. We're going to talk about that in just a moment. So choose Python. That's going to be Python 3.8. And then you can give it a name, or you can let REPL-IT give it the name that it decides randomly. I'm going to call it 30 Days of Python Intro V2, because this is the second session that we're doing to introduce the series. So here we've got our workspace, and we've got a few things. The first thing is here in the middle, you can write your code. So this is where we're going to be writing our code, and if our code produces any output, then that output is going to be shown on the right here. So if we display some data, or if we find some way to interact with a user or anything like that, that's all going to go on the right, and this is known as the console area. I realize I'm getting a bit dark in here. Hopefully you guys can see me okay. Yeah, that's the console area. And finally, all the way on the left, we've got our files. And at the moment, we only have one file called main.py. And this is the file that is going to run whenever we click the run button. My helper has just turned on the light, which is amazing. Whenever you click the run button up here, then main.py is the file that's going to run, and that's the file that we've got open where we're going to write our code. You can create new files, but we're not going to use that feature yet. And then over on the left, you've got your settings as well here, this little cog, and you can change things like the layout if you want, or the theme. You can go to a light theme if you want. The only really important part of the settings is the indent size. I recommend you choose 4, since that's the normal size used in Python. Python relies a lot on indentation in order to determine which pieces of code belong together. So an indent size of 4 is the norm in Python, is what you're going to see in Python programs most of the time, so I recommend you use 4 as well. Other than that, just choose your settings that you like. All right, so now that we're set up, I'm going to just close those tabs on the left and keep only the code editor and the console. Okay. So, the first version of Python was released 30 years ago in 1990, so it's pretty old, but since then the language has undergone a lot of change, and it has grown into one of the most popular programming languages in the world. One of its main strengths is the readability of its code. which makes it really accessible. Often Python code reads just like English, or, well, that's what I like to tell myself. New coders might disagree, but once you start learning a bit more, you'll see that it is similar to English, much more similar to English than some other programming languages, for sure. Python is also really flexible, and it's used in basically everywhere, from machine learning, web development, data analysis, there's automation, there's loads of things you can do with Python. And right now there are two major Python standards in use. There's Python 2 and Python 3. Python 2 has the latest version, Python 2.7. It's technically reached end of life, so we're not going to be seeing any more updates, but there's still a lot of code written in Python 2 out there, so it's good to know about it. The second branch of Python is Python 3, and that's the new Python, modern Python, and the most current version is Python 3.8. Python 3 was intended to be a replacement for Python 2 and has a number of improvements and some significant changes to how you write the code. So an important point to note is that the code written in Python 2 does not necessarily work in Python 3. And sometimes the code runs, but the output it produces is different. That can be quite confusing for you and for any users that are using your code. So do remember to use the correct version of Python whenever you're running your code, or the intended version of Python. Throughout the 30 days of Python, we're going to be working with Python 3, and today we're working in Python 3 as well. Okay, so now that we've got that out of the way, let's start learning some Python. And so the first thing about Python is that Python is very useful in sort of mathematical applications. So naturally, Python, like basically any other programming language, has the concept of numbers. And so you can type something like the number 4, and when you do that, Python is going to be able to look at that number and determine that what you want is to use the value of 4. So that may sound a bit esoteric at the moment, but we'll get to what I mean by that in a moment. That means that in Python, 4 means the mathematical number 4. You can add it to stuff and multiply it and things like that. Similarly, we can use decimal points like 4.5, and now we're talking about this floating point number. 4 on its own was an integer, a whole number, a number without a decimal place. 4.5 is a number with a decimal place, or a floating point number. Because of this, the whole numbers are called ints or integers. The decimal point numbers are called floats. So that's their names. Now you can have negative numbers as well, and that's totally fine. You just put the negative sign in front of them, and Python knows what to do with that. All right. So whenever we run our code, if we run our code here and we say something like 4 and we press run, you'll see that Python does not produce any output. That's because we have to tell Python specifically that we want to display some data to the user. Python by default is not going to display data, so what we do is we use the print function. And so the print function is, a function really is a block of code that somebody else has written for us in the past, and we can use. We can use all functions that Python comes with that are already made available for us to use, and print is one of those. And so the print function is so popular that Python comes with it, so that you can use it right out of the box without having to do any extra work. So in order to use a function or run a function, you type the function name, which is print, and then you type the opening and closing brackets, and it is the opening and closing brackets that tell Python that you are about to run a function. And for the print function, we put what we want to display to the user inside the brackets. So we end up with print, opening bracket, 4, closing bracket. We run this code, and now Python will output 4. All right, hope you guys are still with me in here. And the process of running a function or executing a function is also sometimes called calling a function. So running, executing, calling all mean the same thing, and we normally use calling. So you can print the number 4, you can run this function multiple times if you want, you can run it with many different numbers, and that's totally fine. Python is going to print one number on one line. So 4 then goes to the next line, prints 4.56, and then goes to the next line, minus 15. Okay, Now, before moving on, it's particularly helpful that we learn about a new piece of terminology, which is the word expression. So what is an expression? And we're not going to get into too much detail, but you can think of an expression as anything that Python can look at and calculate, or anything that evaluates to a value. So this is going to make more sense in a moment, but for example, the number 4 is an expression. Python will see that number and it will understand that we want the number to be used in our code. It will be evaluated. And similarly, if we do something like 4 plus 5, we're going to look at mathematical operators in a moment. This is also an expression because Python is going to look at that and it's going to evaluate to a value when it sees it. And the result is going to be 9. So Python evaluates each number. It sort of stores them and allows you to use them. So these are separate expressions, and 4 plus 5 is also an expression that evaluates to 9. As it happens, print is also an expression that has its associated value. We're going to learn more about that later on in the 30 Days of Python series, so if you want to learn more about that, do remember to join in the series later. So now, let's look at expressions in the form of arithmetic operators, so how to do mathematics with Python. Mathematics in Python works in more or less the same way that you would expect your maths in mathematics class to work. So you can add, subtract, multiply, and divide. You can add, you can subtract, you can multiply with the asterisk sign, and you can divide with this / sign. So all of these are the mathematical operators, or some of the mathematical operators we've got in Python. And again, of course, if we run this code, we're not going to get any output because we don't have anything to print, but you can print these things individually and you'll see that you get some output. So I'm going to run this right now, and you'll see that the output is 9, 5, and 10, as you would expect, but the final output is 5.0. So Python has been smart enough to realize that when we use division, we're much more likely to end up with a fraction. So the result of dividing two numbers is always a float, even if the numbers themselves are integers. So notice that if we do 2 times 5.0, so now we are using a float here, the result will stop being 10 and it will become 10.0. So for these three, we must use a float if we want to end up with a float, but for division, we always end up with a float. So that's something interesting to keep in mind. Okay. You can use multiple operators in Python to perform more complicated calculations, like you can add more things here and so on. But just be careful, if you're adding too many things in a row, that's going to become a bit more difficult to read. As well as things get longer, they get more difficult to read. So make sure to use these calculations succinctly if you can. Also, you can chain together different operators, so they don't all have to be plus. You can add some minuses in there, you can add some divisions in there, and some multiplications. And as usual, Python is going to evaluate these things in the order that you would expect from your mathematics classes. That's BODMAS or PEMDAS. So the division and the multiplication are going to happen first, and then addition and subtraction. Now, of course, the first letter of PEMDAS or BODMAS are parentheses or brackets, so they are going to evaluate even earlier. So you can do something like 4 minus 5, for example, and you can put this inside brackets. And now what's going to happen is these two are going to evaluate first, and then they're going to get multiplied together. The result is going to get multiplied together. Now, you can put this whole thing, which is an expression, into the print function. Just don't forget to use the appropriate number of brackets in order to do that. We've got the expression inside here. Print needs the brackets on the outside at the beginning and at the end, so don't forget those. Now we can run this, and we'll see the result is minus 5, because this is minus 1, and this is 5. Minus 1 times 5, minus 5. Yeah, my math's still working in here, so that's good. All right, and so that is a basic primer on numbers in Python. We've learned about printing stuff out using numbers, integers, and floats, as well as the basic mathematical operations that we can use in Python. So now we're going to learn about strings. And strings are things that allow us to store arbitrary collections of symbols. So symbols are anything. They can be letters, they can be numbers, symbols like question marks and things like that. So in a string, we can store arbitrary collections of symbols. So therefore, we can store words, sentences, random strings of letters, numerals, and punctuation. And strings are sometimes called string literals because they literally store whatever it is that we tell them to. So in order to create a string, we use quotation marks. So here we've got a quotation mark at the start and one at the end. And in here, we can put the symbols that we want to store in the string. So we've got these letters, T, H, I, S. We've got the space. Then we've got the exclamation mark down here. All of these individual letters and symbols are stored in this string. When we type this, that's an expression. Python will look at it, it will calculate it, and it will store this somewhere in Python's memory so that we can use it. So we can print it out, for example. And you'll see that Python is going to be talking about the contents of the string. So it's not going to include the quotation marks when we do that. Instead of double quotation marks, you can use single quotation marks if you want. And that's totally fine. Either works. The only thing you can't do, though, is use one of each. If you use one of each, Python's going to get really confused because it's not going to know where the string starts and ends. So just make sure you use the same ones. I'd also advocate for consistency. So I would recommend that if you want to use double quotation marks, you always use double quotation marks. And just it's going to make your programs look like a bit more professional, I guess. Okay. Now, something else to notice is that an empty string like this with nothing inside it is totally valid. It's just empty. It has a length of 0, nothing inside it, but it's still a string. And similarly, if you do the same but with single quotation marks, that's also the same, totally valid. But if you put a space inside the string, this is no longer an empty string. Now this is a string with a single character in it, the space. So a couple of things there that can trip up newer developers, empty strings, strings with only spaces in them. Something to keep in mind, Python does not care about the contents of the string. If you type the number 5 inside a string and you multiply it by the number 3, Python is talking about the symbol 5, not the value 5. So this is going to give you an error if we try to run that. So something to keep in mind. And also if we multiply a string by a number, then you're going to essentially add the string to itself. It's going to be 555. We're going to look at this in a moment, but it ends up with 3 5s instead of the result of the multiplication. Okay, so that is going to come in handy later in the quiz, so don't forget that. And the next thing is naming values. So creating variables, essentially. And that's a vital tool that we're missing at the moment, because right now we can calculate values, we can use mathematics to make calculations, but we can't reuse the values later on in our program. So for example, if we wanted to calculate something like a percentage or something like that, it would be nice if we could store it somewhere so that then we can use it. So when we write something like, 45 plus 56, Python is making this calculation, but it's not storing it for later use. For example, if we do that, and here in line 3, I want to refer back to this result, well, I can't. There's no way, unless I just copy it, right? So instead, we've got variables. And variables are pretty straightforward. You've got the expression on the right. This evaluates to a value. Python is going to calculate that value first of all. Then we have the equal sign and the result, or whatever other name you want to use for your variable. So here we're creating a variable called result, and this name here, result, is a name for the value calculated. So later on we can print result. And when we use the result name here, Python is going to know that because it was defined earlier on, we are talking about the value that was defined earlier. Okay. So I hope everything's clear up till now. Nobody's chatting in the chat. I'm a bit scared that my stream has gone down and nobody's here to tell me. I have notifications turned off, so hopefully nobody's telling me on Discord, you've gone offline. And I don't know about it. So the result is 101. By the way, that was me telling you guys to like talk on the chat, you know. So yeah. 101 is the result variable. So we've got 45 plus 56. That is stored somewhere in Python's memory. And this name here, result, is like a post-it attached to it. Nice one. Thanks, guys. So result is like a post-it note attached to this value that we've calculated. And whenever we use that name, we are talking about the value that was calculated before. So, okay, we're still good. Nice. Emerson, I am from a city called Cordoba, down in the south of Spain. That's okay. I was just kidding. You guys don't have to like type in the chat if you have nothing to say. But yeah. So something, but thank you for letting me know you're still there. Yeah. So here we've got our variable, and we can have more variables. For example, name can be a variable, and it can be Jose. Age is another variable. We can put 90 in there. And here, again, as usual, we're calculating the right-hand side first. This expression evaluates, and the name then gets associated with that. So this variable gets created first, and then this one, because they're on lines 1 and 2. Now, something important about variable names is that you can name them almost whatever you want, but there are a few rules to keep in mind. Variables can have letters, numbers, and underscores, and that's it. So any other character is not valid in a variable name. For example, given dash name, not valid because it has a dash. Given underscore name, valid because it has an underscore, and that's totally fine. First name, not valid because it starts with a number, and variable names can't start with a number, but they can contain numbers later on. So those are two rules. Variable names can contain letters, numbers, or underscores, nothing else, and they can't start with a number, but you can start with an underscore if you want. And finally, variable names are case sensitive, so name is not the same as name. They're just two different things. Python is going to put them in two different places, and you can use them differently and independently. They can have two different values if you want. Okay, now something important is that you have a lot of freedom in how you define your variables, but you shouldn't use capital letters unless you really know what they mean. When you use capital letters in Python variables, they have special meaning, and Python developers are going to know what that meaning is. We don't know what that meaning is just now, so for now, I'd recommend you use only lowercase letters. Also, something else important is that you can name these variables X and Y, and a lot of people do this when they're starting coding. Terrible idea, because X equal Jose, you don't know what that means. That could be my name, it could be the name of some item that I've got on my desk, probably not. But you know, it's not very descriptive, so it's better to use something like first name or given name if you can. These names are going to be much better than these names. All right. So, Hitesh, what inside 4 white walls? Yeah, not quite the case. I have a tiny, green actually, rectangle around me, populated by hundreds of stuff everywhere else, but you just can't see it on camera, so yeah. But I'm glad that that's not apparent on video. So, cool. Let's say that then we've got a simple example where we've got hourly wage is 20.0 and the hours worked is 40. This could be two values that refer to some employee of a company. And here we've got two variables to describe what the values mean and to store them so we can use them later on in our programs. So hourly underscore wage is probably going to be referring to how much this person is going to earn per hour worked, right? That seems reasonable. And hours underscore worked is the number of hours they worked last week. So now, if we want to calculate how much money this person is owed, we just multiply the two together. Hourly wage times hours worked. Again, Python looks at this and it evaluates to the value that was originally associated with it. So this is an expression, this is another expression. Multiplying the two is also an expression, and that results in 800.0 being the result. Now, with this, you can print it out. And again, Python is going to evaluate the expression and calculate the result and print it out, 800.0. Or you can potentially put this into a variable. Amount owed is hourly wage multiplied by hours worked. Make sure to not do that. This is very common, by the way. The stray uppercase letter somewhere in your code, very common. It's going to make your code not work. Amount owed. So now we are calculating this expression beforehand, giving it a name, or giving the result of it a name, amount underscore owed, and then we're referring to that name later on to print it out. Exactly the same thing, just a little bit longer, and it's up to you whether you want to put this inside your print statement or whether you want to create a new variable, what you find easier to read and understand. And readability and ability to understand the code is really the most important thing. So do what you prefer in that sense. Something important, though, that I see a lot of beginners especially doing initially is they forget that you can print stuff out that isn't a string. And sometimes they'll do this. If you do that, what Python is going to do is it's going to print out the individual symbols that are inside the string. It's not going to run the calculation. So you're going to end up with hourly wage times hours worked printed out. So something to be careful about. Okay. All right. And so now that we've learned about this, let's take a look at how to get values from the user. Before that, Hitesh asks, so is it the best practice to verbalize or variabilize? Variabilize, I guess. That's not even a word. Everything. So should you make variables out of everything? The answer is not really. You can use the values on their own and you can, multiply things and calculate them. But normally, a variable is created in order to assign a name that has some meaning to you, to a value. So if you can do that, then that's probably going to be a good idea. So if we can essentially extract this multiplication and give it a name that is more meaningful than the multiplication on its own, then it's probably going to be helpful. So in this case, I think we can get this out and say this is the amount owed in this week. I think that's probably going to be helpful. So if the name that you give the variable allows you to understand your program a bit better, then it's probably worth it. But as you code more, it's going to become more second nature and a bit clearer when to create variables and when it's a bit overkill. So far, we've provided all the values that our code has been using. We've provided them ourselves, but often we want to get values from the user instead. So maybe we want to get the user's name or their age or their wage. And so luckily, Python comes with something, a function that allows us to do that. So just like print allows us to print something out and display to the user, there is another function called input that allows the user to type something back. So I'm just going to write input and then I'm going to run that. Now, when I do that, you'll see that the button at the top stays on this stop position. The program is still running and I can stop it if I want. And really what Python's doing is it's waiting for me to type something and press enter. That's what the input function does. It allows the user to type something out, and when they press enter, the value that they typed is something Python can use. So for example, I can type 50, then I press enter, the program terminates because that's what we've told the program to do. We ask the user for some input and then we do nothing else. So we're going to expand on this program. Often we want to tell the user what they should be typing. So we can put a print statement, enter your age, for example. So Now we've got this print statement above. We're going to see that printed out, and then we've got this ability to type. So here we can type 50, for example, and then the program terminates. Normally, though, we are going to want to put this string here inside the input function instead, because the input function can actually provide its own prompt. And this is the prompt in this case. And what that means, if we allow the input function to take this string, is that the user is going to be able to type on the same line as the text asking them for something, rather than that being on two separate lines. So if they're on the same line, that's going to be a bit nicer. And if we put the prompt in the input function, you can see that that is what happens. That looks a little bit nicer. Something to note is that it's not all that nice when the user is typing and there's this age:50 all joined together. To make this look a little bit better, you should put a space after your colon. That's just going to make things a bit nicer. Now the user can type and it looks a bit better. All of these small things are things that a good attention to detail and a lot of thinking is going to come to you more naturally as you go along. But you should pay attention to, how your users are using your program, what they're feeling when they are interacting with it. Is it looking like a very amateurish program that's not a lot of care has been put into it, or is it looking like you care about these small details? So care about the small details, put spaces after your colons. I will know that you've done that. Your users might not sometimes, but other times they will notice. So yeah, that's where we are so far. We can get people's ages and things like that. So the next thing is to remember that this here is an expression. And because it's an expression, we can assign it to a variable. For example, we can say age equal and then the input call. Now, there's a few things going on here. We've got the expression that is the string. That evaluates first, and Python stores it somewhere so that we can use it. And where we use it is the input function. Input is going to run, and it's going to wait until the user types something and presses enter. And when they do, the value they typed is going to essentially replace this entire thing. So we're going to do age equal, and then, for example, 50 if that's what the user typed. Notice that the input function is always going to give us back a string. So the user types 50, age is the string 50. So if we print age times 2, you know what happens. We end up with 50, 50. 50 twice because we're adding the string 50 to itself. If we want to turn a string into a number so that Python can do mathematics with it, then it's very straightforward. We use the int function, and inside it we put the string. So int of the string 50 is going to create the whole number 50. Float of the string 50 is going to create the floating point number 50.0. So these are the two ways of converting from strings to numbers. Therefore, here we can say int of input. Then that's going to once again calculate the string. Then it's going to ask the user for input and give it us back as a string. And finally, it's going to turn it into an integer, and that is going to be associated with age. Important, and that's something to remember when you're coding in Python, and you'll use it a lot more as you go through the series. Python always evaluates these things in to out, so outwards. The string evaluates first, then the input function, and then the int function. Okay, you can think of it as the brackets achieving that if you want, but really what's happening is the input function needs the string in order to show it to the user, so therefore the string must be calculated first. Similarly, the int function needs something to turn into an integer, therefore the input function is going to be evaluated first. So that's sort of the thinking there behind these things. So that's how we get the age. All right, now let's go back to our hourly wage and hours worked program and see if we can change it to take user input instead of doing it ourselves. So hourly wage is going to be input of enter your hourly wage. remembering the space at the end. And hours worked is equal to input of enter your hours worked. Now, there's a problem here, right, with these definitions. Let's see if you know what it is. Finally, at the end, we can print the hourly wage times the hours worked, or again, like mentioned earlier, we can turn this into a variable, extract it into another line, and refer to that variable separately. All right, so hopefully you know what the problem is with this code. And the problem is, of course, that we need to turn these into numbers. That can be ints or floats. In this case, I'm going to turn the hourly wage into a float and the hours worked into an int. And now we can multiply the two together. So your hourly wage is going to be 15.0, for example, and the hours worked is going to be 20 hours. You end up with $300. Or pounds, depending on your currency. All right, so we've learned a whole bunch of stuff. It's only 45 minutes in right now, and we have already learned about numbers, floating points and integers, printing, user input, strings, mathematics. We've learned a whole bunch of different problems that can arise when you do certain things, like multiplying numbers by strings and things like that. So we've learned a lot of stuff already about the foundations of Python. Now we've got a few questions for you as quizzes that we're going to ask you, see if you guys know the answers. So we're going to start with the very first one right now. Here we've got the first quiz. So we asked these quizzes in the previous live stream as well, and many people got the answers right, but some people didn't. So make sure to think about these. Some of these questions are written as trick questions. So what is the output of this code? 12 plus 5 times 2, and then you print X. You've got A, 34, B, 22, C, nothing, or D, an error. You guys can write in the chat what you believe the answer to be, by the way. So far, everybody believes it to be B, and you guys are correct. Slightly trickier. I think, slightly trickier here. We've got friends equal 9, near equal 3, friends away equal friends minus near. And we've got 3 options: A, 3, B, nothing, C, 6, or D, an error, because you can't use underscores in variable names. So we've got some B's, some A's. The answer is B. The answer is B because there is no print statement in this code, therefore nothing would get printed out. So B is the correct answer. Now this one, actually for this one we need to learn about something else before we teach about this one. So let's quickly jump back to Replit, and I'm going to show you something else that I forgot to cover just a moment ago, and that is the concept of F strings. And so here we've got that 300.0 is the amount that this person earned, probably, in a given week, maybe. But we don't really know that because we've only printed out 300.0. So usually we want to print things out in a bit of a nicer way to give some more information to our users when they're reading stuff. So here's where we may want to put out a string that says you or the employee, or you really, you earned this amount of money last week, right? And so we've got this string here, but we said earlier that if we print this out and we include hourly wage times hours worked inside the string, Python is going to print out the symbols. So this is not going to work. Instead, what we've got in Python 3.6 and later is the concept of an F string. So if we put the letter F before our string, we can then use curly braces, and inside the curly braces, we can put an expression that evaluates to a value. So here we're putting hourly wage times hours worked, and we can see that you earned that amount last week. And now Python is going to be able to do that. You earned 300.0 last week. Now, of course, you can put the $sign in front if you want, and then that's going to print out the $sign, and that's totally acceptable as well, $300.0. Now, of course, like we mentioned before, we can calculate the amount owed to be hourly wage times hours worked, and because if we just put the variable in here, that is still an expression, we can do this instead if we want. So the same thing, again, you can put expressions inside the curly braces, and Python is going to calculate it as long as you are inside an F string. If you're not inside an F string, Python's just going to calculate the symbols themselves without trying to find out what expressions are between the curly braces. Okay, so with this new knowledge, we can now answer quiz 3. So, what would the user see assuming they type Jose? A, enter your name and then Jose and then hello Jose in the next line. B, enter your name and then hello in the next line. C, just enter your name. Or D, just hello Jose. So everything the user would see when interacting with this program, everything that they would see typed out in the console, what would it be? Okay, we've got some A's and D's. People change their mind, but A is the right answer. The reason I say that is because what would the user see? They would see all the input prompt, enter your name, :space. Then they would see the characters they're typing as they type them. And finally, they would see hello and the result of the input function, which was what they typed, Jose in this case, and they would see the exclamation mark as well. So A is the right answer. All right, here we have the final quiz, which is a bit of a trick question. What is the output of this code? What is the output of this code? So give the code a wee read, see what you think, whether it's going to be A, B, C, or D. And the answer, as we're getting a few different things, we're getting A's, B's, and D's. and a couple of C's. And the answer is C. The answer is going to be C, because the user input variable at the start, at line 1, gets a string back. And we mentioned that earlier on in the session. The input function gets a string, so we need to turn the result of that into a number in order to be able to perform mathematics on it. And we also learned earlier on that if we multiply a string by a number, we end up with the string added to itself over and over. So really, if the user types 3, we're going to end up with 11 3s when we multiply the string 3 by 11. So the correct answer is C. All right, so now that we've got this far, this is sort of the end of the session in terms of the teaching involved and the quizzes, but we have a short project for you that we were actually meant to be doing yesterday as well, but then I totally forgot when we were doing this live stream. So I've got a small project for you that we can have a look at. See if you guys want to complete it. So here we've got the project. Hopefully you guys can read it. I'm actually going to leave the camera so you guys can see this. And here we've got this project. So the project is to build a simple tax calculator for a fictitious country. So for this project, we need to take 3 pieces of data from the user. We need to take their income, that as an example might be 100, the local tax rate, for example 20%, and the federal tax rate, for example 7.5%. And the application is going to calculate the amount of local and federal taxes due, as well as how much money is left over. And here's how they're calculated. Local taxes are taken directly from income. So for example, if the user makes $100 and the local tax rate is 20%, then that's going to be $20. And federal taxes are taken from what's left over. So $80 were left over, federal taxes is 7.5%, so that's $6, 7.5% times 80. The user is left with $74 after paying both sets of taxes. Okay, so again, we're going to have to do a couple of things in this project. I'm going to give you a few minutes to try to complete this project. We need the income as a number, the tax rate, and that can be for 20%, for example, 0.2, so that's a float, and the federal tax rate, which is also a float. Then we're going to take the income and see how much local tax we have to pay, and then we're going to subtract the local tax from the income to end up with what's left over after paying local taxes. We're going to do the same with the federal taxes, and finally we're going to print out how much money is left over and how much were the local and the federal taxes. So I'm going to leave this screen in here for 5 minutes, and then I will start implementing this project. So I would recommend you launch REPL 8 right now and give this a go. See what you can come up with in terms of implementing this project. And don't worry at all if you are a little bit confused or you're completely stuck. That's totally fine. Give it a go, try to type some code out, and then we're going to go over it together, and we will sort of guide you through how we would implement this, and that's really going to help you learn. Actually, writing some code is the key part of learning to code. So I'll give you a few minutes to try to tackle this project. I will turn the audio off because I'll be too distracting otherwise, and then I will come back and I will show you how I would do this. So give it a go. I'll see you in a couple of minutes. Hope it's going well, guys. Let me know if you are stuck or done, and then we will continue in a couple of minutes. Yep, Phil is totally right. If you are very stuck, you can join the Discord server right now and say hello there. The Discord server is going to come in really handy during the 30 days of Python, because that's where we will be providing help to anybody who is a bit stuck or just wants some help or just wants to chat with us about coding. So you can join that if you're just waiting. And in just a couple of minutes, we will go through the solution. All right, so that was about 10 minutes. I would say we're going to go ahead and code the solution with you guys. So there we've got REPL it, and we have our camera, which is kind of messed up right now. We're going to fix it. Did we fix it? We didn't fix it, did we? Well, the camera is a bit messed up, I think, but hopefully that's all right with you guys. I can see these lines going up. That's due to the frequency of the camera refresh rate. But hopefully it's not too distracting. We've got REPL it again. We are going to go ahead and write out the solution and guide you through how we would do it. So yeah, let's do it. The first thing to do is to think about the data that our program needs. So we mentioned earlier that we're going to need the income of the person, we're going to need the tax rates, the local tax rate and the federal tax rate. So the income is going to be a float of input, and we're going to ask the user to enter your income, something like that. Now, remember, I'm turning this into a float because income could potentially have some cents or pence in there, so we're going to use float for that reason. Now, the tax rate is going to be local tax rate. Notice how I'm using underscores here instead of spaces, and no uppercase letters whatsoever. This is also going to be a float. Now, something we could do here is we could use an integer instead. And yeah, we could use an integer instead and make some more calculations in here, but we're going to use a float and we're going to say input, enter your local tax rate as a decimal. So 0.2, for example. And finally, we've got the federal tax rate, which is going to be the float of the input, enter your federal tax rate as a decimal. So now, if we run this code, we're going to be asking the user for three things. Your income, your local tax rate as a decimal, such as 0.2, and your federal tax rate as a decimal, such as 0.075, like we had in our example. Nothing is happening with this information because we've collected the data, but we've not done any multiplication. We've not printed anything out. So the program ends as soon as we type that out. So the next step is to make the calculations or this data processing that is going to allow us to detect how much tax this person paid. So the amount of tax, local tax amount, is going to be equal to the income multiplied by the local tax rate. Pretty straightforward there. But this tells us, for example, if they entered 100 and 0.2, that the local tax amount is 100 times 0.2, so 20. Now we need to subtract from income the $20. So we'll say leftover after local is going to be income minus the local tax amount. And so here we've created a new variable called leftover after local, and that's going to be the income minus the local tax amount. Okay, and better name, post local tax income. That might be a better name. So just something to keep in mind, your variable names, they can sometimes not be all that good. Rethinking about the variable names at times can be helpful to come up with better ones. So now that we've got that, we can calculate the federal tax amount, and that's going to be not the income times the federal tax rate, but the post local tax income times the federal tax rate. Make this a little bit bigger just so that goes into the same line. And now post federal tax income is the post local tax income minus the federal tax amount. So again, we're taking from this the federal taxes. And now we've got this is what's left over after both sets of taxes. Okay? You can also call that final income if you want. Final income. It's a little bit shorter, so it's going to help us keep it in one line. In this case, I'm going to go for that. Now what we have to do is we have to print out how many taxes the user paid and what they're left over with. So we will print with an F string, you paid, and then how many local tax amount, local taxes. So, for example, you paid 20 local taxes. And we can do print, you paid a federal tax amount, federal taxes. And that, if we run it, it's going to leave us with, for example, 100, 0.2, 0.075. You pay 20.0 local taxes and 6.0 federal taxes. Finally, we want to print how much money is left over. So we'll do print. You have final income left over after taxes. And now if we run this and we type in 100 and we type 0.2 and 0.075, we have 26 and 74 left over after taxes. We can put the dollar sign in front of all of these to make it look a little bit nicer. And now we get the dollar and so forth. All right. So this is the tax calculator. This is the project that we wanted to build with you in this session. I know that this is a little bit longer than any of the other pieces of code that we've seen in this stream, and I appreciate that as you actually start to want to use the code and write something that may be useful for you, it becomes a little bit trickier. But you have to go through it line by line, try to think about what data you want and what you want to end up with. Creating many variables like I've done here is totally fine. If it allows you to think about your programs better, then you can totally go for that. Replit does that sometimes, by the way, just sort of reloads, but you still get to keep your code, so it's all okay. So this is the project. Hopefully you guys were able to implement it, or at least get some of the way through. Hopefully going through it with me here helps a little bit. We're going to have a lot more projects in the 30 Days of Python. So let me talk briefly about that. And this is the 30 Days of Python. So again, as I mentioned at the start of the live stream, 30 Days of Python, one blog post a day, where we have a very well written, very well explained Python set of concepts. Then we have exercises, which are really good. They're going to help you cement the knowledge gained by the blog post. Every 3 days and every 7 days, we also have a project. Whenever we do a project, we will have a video associated with that guides you through the solution in case you get stuck or you want to see how we would implement the project. And the series is going to guide you through all of the fundamentals of Python, from numbers and strings to functions, dictionaries, sets, all that sort of stuff that you may want to use, files and all that stuff. So it's going to guide you through a lot of the fundamentals of Python. And not only that, but throughout the entire 30 days and beyond, really, you can get personalized help and find when we post new days of the 30 Days of Python by joining our Discord server or following us on Twitter. So you can get personalized help, you can post your code on Discord, we will help you out, we will give you feedback, suggestions, and things like that. And if you have any questions, you can ask them as well. You can use the Python channel on Discord, since that's where we ask and answer Python questions. But that is 30 Days of Python. So my advice now would be to follow us on Twitter, to get the new announcements of when we post every day, starting tomorrow. Tomorrow is the first day. Join the Discord channel so that you can ask questions there if you have any. If you do those two things, you're going to be set for the next 30 days. And the amount of time that it should take is more or less 1 hour a day, 30 minutes to 60 minutes a day, to read through the blog post, to do the exercises, and to complete the projects. So yeah, I think this is a great opportunity to really make use of this lockdown, learn to code. If it's something you've been wanting to do, you have our help and the content that we have written, and we think that is going to be really helpful, especially if you're new to coding. But even if you're not fully new, it's still going to be helpful because it goes through everything and explains sort of why and how things work. And we've got the exercises and the projects as well to help you out. So if you've got any questions, ask away in the live chat right now, or join the Discord server and ask us there. We are more than happy to help you out. Thank you guys for your kind words. Thanks for tuning into the live stream. Thanks to Phil as well for sticking around, helping answer questions, and of course for writing the 30 Days of Python content. So if you guys like Phil and what he's been doing, you should stick around to check out the series because it's very good. Also, I'll ask you at this point what you thought of the video and audio quality in this live stream. If you thought it was good, let me know. If you thought it was not good, let me know. Reminder also, just in case it's not clear, every day we're going to post a blog post. We're not going live every day. That would be the end of me. I am not a live streamer as a profession, so we're not going live every day. We are posting a blog post every day, and every 3 days and every 7 days we've got a project. Those projects come with video to help you solve them. Video and audio was really good. Video okay. Audio was really quiet. Okay, that's not good. It stalled once or twice for a couple seconds. Yes. Excellent quality. Okay. Oh, very good. Oh, very good. Amazing. Pardon me. managed to hit the mute button there right before blowing your eardrums. Very good. Yes, it buffers every so often. We've got around 10% dropped frames, which is a lot. But my laptop just cannot cope. But thank you guys for letting me know. I'm glad that it was okay. Slight lag. Yes, it's true. Okay, I'm glad that the video and audio was acceptable at least. Okay, so that's really it for today. Thank you for tuning in, guys. I really appreciate it. Thank you for watching and for joining us and for answering our quizzes and hopefully attempting your project. Remember to follow us on Twitter, link below in the description, and join the Discord server. And I hope to see you tomorrow for the first day of the 30 Days of Python. We're really excited to release that. So yeah, looking forward to working with you guys on that. If you've got any questions, again, join the Discord server. We'll be more than happy to help you out there. But for now, we're going to call it a day in this live stream. And yeah, thanks guys again. I'll see you around.